Now let's look at centrifugal clutch. A centrifugal clutch is a clutch that uses centrifugal force to connect two concentric shafts. The driving shaft is nested inside the driven shaft. So this is the cross section and this is the front view. So what happens is the driving shaft contains the spider mechanism, and in this spider mechanism you will have your spring as well as the shoe, and this shoe is simply your centrifugal clutch or the clutch plate. So generally when the driving shaft is stationary, you'll see that the spring force is greater than the centrifugal force, so it will hold on to the shoe, and there is no direct contact between the shoe and the inner diameter of this driven shaft. As a result of that, no transfer of motion from the driving to the driven. So once this driving shaft starts to rotate, you'll see that, or you will notice that the centrifugal force will increase. So as the speed increases, the centrifugal force increases, and it will come to a point when the centrifugal force which acts outward is greater than the spring force which is holding that shoe in place. So once the centrifugal force is greater than that spring force, the shoe will come in contact with the driven shaft, and as the speed increases, the shoe's force or press onto the driven shaft with a greater force, and as a result of that, more torque is transferred. So the transmission of motion between the driving and the driven shaft is only possible when the centrifugal force is greater than the spring force. So these are few examples and few different configurations of a centrifugal clutch. So what generally happens is the shoes move radially in guides and are held against a spider on the driving shaft by means of springs. The springs exert a radially inward force. The weight of the shoe when rotating causes radially outward acting force, and this is known as your centrifugal force. Now what happens is when the centrifugal force is less than the spring force, the shoes remain in the same position, and there is no transmission of force, there is no transmission of motion from the driving to the driven. So what happens then is when the centrifugal force exceeds the spring force, the shoes move outwards and they come in contact with the driven member and press against it. The force with which the shoes press against the driven member is the difference between the centrifugal force and the spring force. Now what happens is when the increase in the speed will cause the shoe to press harder and harder onto the driven shaft, and as a result of that, more torque is transferred. So now let's look at the analysis of a centrifugal clutch. M is the mass of each shoe, N is the number of shoes, R is the distance of the center of gravity, small r. Capital R is the inside radius of the pulley rim. Omega is your angular speed. Mu is your coefficient of friction. L is the contact length of the shoe, which is simply theta r. B is the width of the shoe. Theta is the subtended angle or the angle subtended by the shoe, which is given is radian. And P is the intensity of pressure exerted on the shoe. So again, the two things that are very important here are these two parameters. Small r is the distance of the center of gravity, and capital R is the inside radius of the pulley rim. So firstly, using equation 18, we can calculate our centrifugal force Fc, which is given by m omega squared r, and r is the distance to the center of gravity. M is the mass and omega is the rotational speed or the angular velocity of that particular centrifugal clutch system. The spring force is given by 9/16 m omega squared r. So we said that the net force which is acting is simply the difference between your centrifugal force and your spring force. So equation 18 minus equation 18 gives you equation 20. So your net force is simply 7/16 m omega squared r. And the frictional force is nothing but your coefficient of friction times your F net, and the torque is nothing but your net force times the times the inside radius of the rim, which is your capital R, so which is simply given by mu F net R. So equation 22 is very important. And then what we have is the contact length, width of the shoe, and the pressure is related by equation 23. So first we will pay attention up till equation 22, and we will not look at the geometric length of the shoe itself. So once more, what happens is the frictional force is nothing but mu times your net force, and your net force is the difference between your centrifugal force minus your spring force. And then your torque is nothing but your frictional force times your inside radius of the rim. And equation 22 is simply obtained by substituting for F from equation 21. So now let's look at example 5. A centrifugal clutch is to be designed to transmit 15 kilowatt of power at a speed of 900 revolutions per minute. There are 4 shoes in total. The subtended angle is 60 degrees. The inside radius of the pulley rim is 150 mm and the distance from the center of gravity is 120 mm. The coefficient of friction is given as 0.25 and the pressure is 100 kilopascal. So you have to determine the mesh of the shoe. So basically we'll start with this equation. Power is tau omega. Power was given as 15 kilowatt. Omega, we can calculate our angular velocity based on the speed, the rotational speed, which was given as 900 revolutions per minute. So substituting everything into this equation, we get our angular velocity as 94.25 rads per second. So we can find our torque. Torque is nothing but power divided by our angular velocity, and we get a torque of 159.15 Newton meter. The next thing is we need to calculate our F net, and we know that our F net is nothing but the difference between our centrifugal force minus the spring force, and this is given as 7/16 m omega squared R. We don't know our value of mass m, so we just leave it as m. Omega was 94.25, and then R, which is the distance to the center of gravity, was given as 120 mm. So converting it to meters, substituting into this equation, we get our F net as 466.36 m, which is your mass Newton. And we know that our torque is simply equal to F R. F is your net force and R is the radius or inside radius of the rim. Now what happens is we know in total there are 4 shoes, so N mu F net R. So number of shoes was 4, mu was given as 0.25. Our F net is simply over here, so you can substitute it here and just leave it as 466.36 m, and the inside radius of the rim was given as 150 mm. So converting it to meters is 0.15, and what we can do is we can solve for m, which is the mass of the shoe. So the mass of each shoe is simply 2.28 kg.